Hello everyone, good afternoon. My name is Ali. I will be presenting for chapter 5.1 and 5.2. So we have reached the section of the textbook where we will discuss about the application of features, and we are covering the role of features in design. So in 5.1 I will explain about feature-based part creation, and in 5.2 I will explain about feature identification. So a brief recap about features. We know that features have engineering intent, and they're a constituent of parts. And they're useful for our design task because they can help in creating part geometry, as well as specifying tolerances and creating assembly design, such as for configurations. And in addition to all that, we also the features can also help us with analyzing during the design stage without doing any physical testing to save time and costs. And this is possible with numerical or knowledge-based systems, such as for stress analysis with FEM, or maybe manufacturability evaluation and cost estimations. So feature-based part creation. So basically, there are two main benefits of using features. The first one is the ease and speed. Basically, it's simple and easy. Then the second one is that changes made in features can propagate throughout the design. And how can this be? So for the first reason, it's ease and speed. This is because features is a collection of entities with predefined attributes. The word feature itself literally means a distinct attribute. So there is something stereotypical, something distinct about that part that makes it a feature. And this can help us because all we have to do is select an instance of feature. We can select any feature we want, and then we just have to fill in the parameters that we want through a GUI or something similar from a feature library. We will select the instance of the feature from a feature library. And this feature library will consist of all kinds of generic characteristics that may be important during the design process. So as a very simple analogy, it's like creating a circle using any CAD software. We select the circle, which is the feature. Then we use the mouse to select the point, the center point, and drag it to create some specified radius. Then for our second reason, features can help us save time because they have geometric constraints. With these geometric constraints, any changes in a feature can propagate to other parts of the project. And these geometric constraints are stored whether in the intrinsic form or extrinsic form. Intrinsic, as we know, is that it belongs to the one single feature itself, when extrinsic is any relations that it has with other features. And then with these geometric constraints, the system itself will automatically calculate any parametric changes and propagate this change to all the other feature parts that depends on our feature. So, as an example, this is an ANC-101 part. This is made by ChemI using advanced numerical computing. And this part has no specific purpose. It just to show what kind of part is possible to be made using features. So I will go through the process of creating this part in a bit. But as an example, we will have this generic feature library. So our generic feature library will consist of maybe a block and a wedge. And these features will contain 3 parameters. And these parameters can be summarized into independent dimensions, derived dimensions, or constraint dimensions, and parameters that depends on the positioning of the feature with respect to other features. basically its relation with the other features. So back to our feature library. For our block, we have these independent dimensions, basically the length, width, and height, almost similar with the wedge. And then for positioning, we can either have the world coordinates or the face of another block. And then some other features that may exist in our library could be 3 different kinds of holes. So for these holes, the positioning parameter is much more important because we need to specify the XY distance from the reference edges or from the faces that our hole must be made from. So we have 3 different holes here: the through hole, the blind hole, and the double C-bore hole. So for the counter bore hole, we can actually consider this as a composite feature. It consists of these 2 other features. But this is up to our preference. And for example, if the preference is if we use this feature often enough, and maybe it is preferable for us to define this feature as a unique feature. Then some other kinds of features available could be like base, or a blind slot, or a pocket. The pocket here is like some sort of empty space within the part. And some more features, such as the boss, the recess, and the rib. How can we utilize these features to create our earlier part? Oh, another thing. There's a features can also be defined as patterns called feature patterns, and this could be a circular hole pattern or rectangular hole pattern or symmetric pockets. And these patterns are generic in that we can define them as features because we can have different kinds of holes to utilize this pattern. And yes, so any kind of hole that we want can utilize this pattern and following the parameters that the pattern gives. And in this case, it's not a hole, but we can have any kind of pocket that we want following this feature. So how can we utilize these features for creating our part? So we can first start with a base. An instance of base is a world coordinate, and then we can add a block on top of the base. So all these are basic steps. After the block, we can add the wedge, and then after that, we can add a boss and a rib or a pad. And these 2 depends on the faces of the wedge and block. And going further, we can create a double C-bore on the top face and a blind hole on the center of the boss. And then we can also continue with using a circular hole pattern around the C-bore for our holes and creating pockets, symmetrical pockets in the front side there, and creating a rectangular hole pattern here as well. As mentioned earlier, features allows us to change a specific part, and if the part and the change will propagate to other features that depends on that feature. So, because of the constraints earlier, this thing is automatically recalculated, and the feature is repositioned if their parent entity is modified. So, for example, if we want to move this block to a different position in the base, all the other parts, the boss, the C-bore hole, and the pad will also move along with the block because of the geometric constraints. And so for our next section, I will be discussing about feature identification. Basically, for feature identification is that commercial software will provide us all the basic features, all the basic predefined features that we want. But if us as a company wants to create a product if we create a unique product, and that product requires specific parts, and we use that specific parts often enough, we might want to create and identify our own feature. Feature creation here is not the creating a feature mathematically. This is creating a feature like defining a new word and putting it in a dictionary. So the process of feature creation is identification, formalize, and archival. So we first need to identify what part of the portion in our product is unique enough, is stereotypical enough, and is used often enough that we can use it a lot, and we need to define a feature to save time. And then after that, we need to formalize this this specific part, by defining or articulating all the properties that it needs. Once that's done, we need to store that feature for future use. So can anybody tell me what this part is?
Hinge, maybe range.
This is what's called a truck, and it is used here for a skateboard. So if you're a skateboard company, you might often need to manufacture this part a lot of times, and so this part will require specific features that you may need to define. Probably like this T-shape, or maybe this base, or other kinds of T-shapes. So for the first two steps of identifying and defining the feature, we will have to first, there's a methodology to identify and formalize this part. So the first one is that we can look at the feature and forget any kind of relation it has to the overall product. And when we look at this feature individually, we do not know how the feature is related to other parts, how it is located, or how it can affect other parts of the feature. We just want to look at something specific, something that we can call a feature, some section that is unique. But to know all the other things, we need to look at the steps during the design process. So what we want is to observe the physical embodiment of each design stages. So at every design stage, we can see how a feature is added into it and how that feature will affect the input and output of the overall design, so that we can define the feature itself. Once we've done this, we can also do either reconciliation or some trade-off decision making. So for reconciliation, we can reconfirm or affirm the information of the features that we have identified. For example, we can identify all the necessary properties and all the dimensions, necessary parameters, or how they can be connected to other features, something like that. And for trade-offs, we need to somehow justify the process of identifying and confirming our feature. And what we do here is that we are trying to make, so the goal of identifying the feature is to save time during the design process, so we don't have to create anything else from scratch every time. So the feature has to be used often enough for it to justify us identifying them. So if the feature is not used often enough, we rarely use it, it's probably much faster sometimes to create it geometrically. Then how specific should the features be? If the feature is not that specific, we don't have to define the feature. So there's some questions that we need to discuss about how specific do we want the feature to be? Because if the feature is too specific, the what's the word? The task that you can apply to them is much more limited than when it's much more general. Then all these processes can be summarized into a PPO, the product process on organization resource. Then we discussed identification and affirming the attributes. So after that, we need to validate the candidate of the features for archival purposes. There are 4 criteria that we need to see in order to validate. That is the completeness of the feature, whether this feature is already finished or you can it's already finished to be used for any part of the design, or that the definition is not complete yet. Then the parameters of the feature needs to be fully defined as well. So we need to know what each property is required by the feature and what they actually represent in the feature. And the feature also needs to be simple enough in that the properties are only used for the specific application of the feature. And then you want to make sure that the feature that you have identified is not a duplicate of different feature. That is that they don't have any identical properties or uses, because otherwise you can just use the earlier defined feature. So we can do a case study for the feature using an automotive body panel. So say we want to develop a body panel for a car door. And here you can see the door regulator mechanism, a basic diagram. And the key reference point that we want to look maybe is the main pivot. And from this main pivot, we can create this workspace. And we can start by creating a main pivot hole and a bead along with rivet holes to hold the mechanism to the panel. And this combination can actually be defined as a composite feature if the connection to that main pivot is similar enough in other projects or in other products. Once we've created the main pivot hole and its surrounding features, we can then decide on creating the crank pocket. And we can decide the position of the crank pocket with respect to the position of the main pivot, as you can see here. Right? We can just refer to the mechanism and the relative coordinates of the crank to the main pivot. And then after that, we can make a motor pocket as well. And this motor pocket can, instead of being relative to the main pivot hole, it can be relative to the crank pocket to determine the position where we want to put it in the back panel. And once that's done, the secondary pivot holes can also be considered from the relative coordinates of the main pivot hole for the connection. And once everything's done, we have to create fastener holes to the back panel to connect it to the regulator, to the door mechanism earlier, and also creates a trim line. So for this body panel, they contain all these simple features. Basically, we have a circular hole, a rectangular hole, a bead, rectangular or circular pockets, and flange. The flange is not there yet, but you can see all these simple features. And after that, you can proceed in the design stage again, going to the next design stage. You can add more features, and for it to look like this, we can add a perimeter flange, and we can also add right beads, and the right beads will depend on the position to the main pivot part. And then we can also add maybe a spring retention pocket for a different component. So once we've added more features, our body panel will now contain a pattern feature, which is the main pivot pattern. as you can see here, main pivot pattern, and the gear right beads. The gear right beads. Then we also have our compound features, which is a spring retention pocket made out of a pocket and a hole, and the crank pocket made out of other various parts. So before ending my lecture, I want to show you guys a video. Maybe the speaker is not necessary. So this is a bookshelf, as you can see. And now we can use our design library to select a specific feature. In this case, I'm not exactly sure what it's called, and it's not very clear in the video. So we can add it. Again, user interface to put this feature in our design model. So once we've selected all the necessary parameters, the feature is added to the model directly. And imagine if you have to make that part from scratch, and that part is not defined in the feature library. So the feature library, the feature-based modeling actually helps us save time. And that's it for my lecture. Thank you. Any questions?